Now our application is up and running and food type and category are working as expected. But in a typical application, we do not access the DB context directly. What we rather do is we have a repository pattern and we use that for all the operation. So in order to get started with that, we will implement our repository inside the data access project. So let me right click there. We will add a new folder which will be repository. Inside that repository, we will create an interface pattern. So we will add a new folder which will be iRepository. We will be using all of this with dependency injection, so interface and class will be the generic pattern. First thing that we will do is inside the iRepository, let's add an interface which will be iRepository. Let's add that. This will be a public class, and when we work with a repository, it will be on a generic class. Like if we examine our models, we have category and food type. We want to implement a repository that will be generic, so that whatever class we provide, it is able to execute that on that particular class. We will be using a generic repository. That's why we will be using a T here, which will be generic. We will just say where this T that we have used could be any class. That is the general definition that we have for our repository. We don't want the internal, we can remove that, and then this iRepository will have some generic method. Like when we are working with database, what are some things that are common? The common methods could be get all of the records, get record by ID, which will be similar to first or default. Next we have add a record, remove a record, and maybe we want to remove a range of records. So for that we have remove range. These are general things that we are doing already inside our category and food type when we are performing the CRUD operations. But this time we do not want anyone to access the DB context directly. They should go through our repository. So we need all of the generic methods inside our iRepository. We will start with the simple ones. First method that we will add will return void, and that will be add. And when we add anything to the database, we just pass the entity. Let's examine that in our Abby web project. If we examine our create page model here, you can see when we are adding something, we are just passing that entity. Here we know that this is of type category, but inside our repository, this will be a generic type, which will be T. Next, we need to do the same for remove. So we will paste this. When we want to remove anything, we will pass the entity right here. Then if we have remove range, it will be a range or a list of object. So we will have an IEnumerable of T here. We will call that the same as entity, and the method name here will be remove range. So with that we can perform add and remove operations. Now the last one that remains is get all and get something by ID or first or default. So when we are getting all of the objects, it is possible that we want to filter some of the request. Like let's say we have product and we want to get all the products whose price is greater than $10. So first we will have an IEnumerable that will be return type IEnumerable of T, because if we want get all products, it should return an IEnumerable or a list of all the product. So the return type will be an IEnumerable of T. Next, the method name, we will call that as getAll. Now here, do we want any parameters or not? Right now, let's keep things simple, and getAll will return all of the records from the database. In future, when we have more complex requirements, we will add that to our getAll. The last one that we have is get first or default or get something by ID. That will return only one record, so the return type will be T, and let me call this method as get first or default. So it will return only one record. Now if we examine our edit page model, you will notice I have written few statements here when we are using first.default. So you can see right here, when we want to use first.default, we are passing a function that will evaluate and return the data. So if we implement a generic repository, we should expect a function like this. To expect that in the parameter, we have an expression that we can use. So here the type will be an expression. We will press Ctrl dot to add the link dot expressions, and in here we will get a function. So function will be t, comma, the output will be a boolean flag, and we can call this as filter. This can be null as well. So let's add that. And if this is null, we will add a question mark here to denote this can be a nullable field. Now if this does not make sense at all, we are just adding here an expression, and we are adding that because if we go to edit, when in the parameter, if we want an expression like you have here, this can be expected only if you write this in the parameters. So that being said, we have implemented the generic definition for first.default, get all, add, remove, and remove range. With that in place, let's implement our repository in the next video. Also right now, if this repository is not making much sense, please stay with me till end of the section. I promise when everything comes together, it will make much more sense. So let's implement this repository in the next video. Now that we have added the iRepository, we need to implement that in a class file. So inside the repository folder, we will add a new class here, and that will be repository. Let me add that class, and we want to implement our iRepository interface. We will make this a public class. It will implement the iRepository. If you write just iRepository, you will see an error message because it has to be a generic. Then if we examine our iRepository, this will be on a generic class. So repository will also be on a generic class. So we will write t right here, and then we will add the using statement for data access.repository.iRepository. Then here again we have to define what is t. So we will say where t will be a class. With that, let's hover on the squiggly lines here, and we will implement the interface. So show potential fixes, and we will click implement interface. Here we will have to perform operations on our database. If we examine the create or edit page model, when we had to work with database, we were using application DB context. So what we want is inside repository, we will have to use the DB context to actually make all the operations. But from the front-end pages, we will be using our repository. So here we need dependency injection, and using that we need the application DB context, just like we added inside the edit page model. So you can just copy these few lines from the top, and we will paste that in our repository. We do not need category, we just need the application DB context. The constructor name will be repository, and we will do Ctrl dot to add the using statement for our DB context. Then what we used to do is on this DB, we used to perform all the operations. But this DB internally uses the DB set that we have defined right here. So we can use that DB set to perform the internal operation. We will add a generic DB set here, and I will call that as DB set. We need to bind the DB set from the application DB context that we receive here. So we can say this.db set is equal to from our DB we want to set the context. So we will call set of t here, and that will bind everything to this particular DB set. And DB set now can be used to perform all the operations like we were doing with Entity Framework Core inside all the pages like edit.cshtml right here. If this is too much right now, do not worry. This is just internals of how DB set and the DB context work with each other. Let me show you how we can perform the add operation and you will see how closely the DB set resembles with the application DB context. In order to add anything to the database, we will be using DB set. On there we have the add, and we just pass entity that we received. Exactly same as what we did with our DB context. So that is pretty simple. Next, let me copy this and implement the simple one, which is remove, where we have the remove method right here. Lastly, when we have remove range, we have a method that directly implements remove range, and it expects an IEnumerable. That is what we receive here, so this will also work. So those three were pretty easy. Now we have a get all. What that should do is it should return all of the objects from database for that particular DB set. So here we will be creating an iQueryable because it is possible that you want to query on this DB set. So we will call that as query is equal to DB set. So from DB set we get an iQueryable, and then we just want to return query.toList. That is exactly what we did inside index. If we take a look at any of the page model for index, you can see we just had the class name and we return the list. So let me close those two, and get all is super simple. The last one that we have, get first or default, is a little bit complex, because here if you examine where we have the first or default, it gives an expression and we have to evaluate that expression. So let's implement that. We will go back to our repository. Let me copy the iQueryable, paste it in first or default. Here we will have expression in filter. So we will say if filter is not null, then we want to evaluate the first or default. So we will say query is equal to query dot. We have first or default. All the methods are same that were there on the DB context. So inside first or default, we will pass the filter that was received as parameter. Once you write that, you will run into an error message because of the typecasting. You can explicitly typecast there, or you can just use a where condition here, because when we have a where block, we will have multiple condition. If we go back to edit, you can see first or default can also be achieved with a where condition here, and then we append first or default at the end. So let's use the same method in our repository. Let me comment that out. First we will use a where condition and filter everything based on what we receive in parameters here, and after we receive that, when we return back, we will not return the complete list. We will say return query. On that, we will return the first or default. That way, our method will only return the first or default. With that, our repository looks great and all the methods have been implemented. But now we need to understand how we will be able to use this generic repository instead of DB context when we were working on CRUD operations in categories and food type. Let's do that in the next video. Now we have our generic repository, which has few methods to add something, get all, get first or default, and remove something. But if you notice here, we do not have the update functionality. When you are updating an entity, it is possible that update for one entity might differ with the other entity, and you want some customization. That is why I always like to keep the update statements out of my generic repository. Also, if you go back to edit here, and if you notice when we update or even when we create something, after we add, we need to save the changes. Only after save changes, the database changes are actually pushed to the database. So right now we do not have update or save the changes. That will be implemented in the individual repository that will use this generic repository. So now the big question is we need to implement a repository for each of our DB set. That will again be inside the iRepository and the repository folder. So inside the iRepository, let me add a new interface here. and I will call this iCategory repository. This iCategory repository will implement the iRepository, but if you examine the iRepository is on a generic class. When we are working on category repository, we know that the class will be category, so we can define that and add the using statement. So this way we are using the generic repository inside the category repository. So if someone wants the category repository, they will get all the methods inside the iRepository by default. On top of that, we want two more methods inside the category repository. First one is void update to update the category object. So it will expect a category object that needs to be updated. And the next method here will be to save the changes. So we will call this method as save to actually save all the changes in the database. So our interface looks good. Let's implement that inside the repository folder. So we will add a new class here, and that will be category repository. This will be a public class, and this class will implement the iCategory repository. We will press Ctrl dot for the using statement, and let's implement the interface. Now if you click implement interface, you can see in the snippet here that it is going to implement all of the methods that we have already defined. You can see it is adding add, get all, get first or default, remove, remove range. Those are already defined inside the repository class. So here, along with iCategory repository, we will need the repository, and that repository will be on the category model. Now once you make this change, you will see some squiggly errors. And the reason behind that is the base class repository must come before any interface. So we will have to cut this, and we will have to paste that before the interface and its implementation. Perfect, one error is gone. Next, if we try to implement the interface this time, it is only implementing two custom methods, that is save and update. And that is exactly how we want this to be. After we fix that error, we have one more error here, and if we hover, it says there is no argument given that corresponds to the required formal parameter db of the repository. That is because if we examine the repository class, you can see it is expecting an application db context in the parameters when an object is created. So if we go to our category repository, we need to extract application db context using dependency injection. That we did inside the application db context. Here we were passing to the base class. Similarly, we will have to pass to the base class so repository can get its object. So first we will have to create a private read-only application db context. We will call that _db, and then using constructor, we will get an implementation using dependency injection. But main thing here is we have to pass that implementation to the base class. Once we do that, you can see the error goes away, and here we will assign that to our local variable. Now we have application db context in this repository, so it's easy to implement the save method. All we have to do is _db dot save changes, and that looks good. Last but not the least, we have to implement the update method. Now if you go to our categories and we click on edit, you can examine where we are updating the category. We just called the update statement. This is one way of updating a category. And when you call this update statement, it goes through all the properties of category. We only have three: ID, name, and display order. So it will update the name and display order. Even though they are not changed, it will update them to what it gets in the category object. Now let's say what you want to do is you just want to update name every time, and display order is a property that can never be updated. How do you accomplish that? Using the update statement, you cannot accomplish that thing. So inside the repository, let me show you another way of updating a category or any object. So first we will have to retrieve that object from the database. So we will say obj from db is equal to, let's retrieve the category object from database based on the ID that is inside this category right here. So we will say underscore db dot category dot first dot default. We want to retrieve that based on the ID. So u goes to u.id is equal to category.id. That will retrieve the category object from database. Now when you retrieve anything using Entity Framework, it automatically tracks that entity. Since that entity is tracked, you can directly modify the properties in there. So here we will change the name to the name that we have inside the category object. We also want to update the display order, so let me do that. Once we update that, we can manually call the save method that we have implemented. Once we make all of these changes, last step will be to call the save method that we will do when we call the repository. But with this, our update looks good. Now if you only wanted to update name, you can comment out this display order. What that will do is it will let you select only some properties that you want to update rather than updating the complete object. So this is another way of updating using Entity Framework Core. Since Entity Framework Core, when it retrieves category, it stores and tracks that. So if you update any properties of this object and hit Save Changes, it will automatically go to the category table and update them based on the ID. It is pretty smart and convenient. So with this now in our category repository, we have all the functionality that is needed to replace the application DB context inside our Blazor pages. Let me show you that in the next video. Before I show you the best way of using the repository pattern, let me use this category repository inside our category pages. When we are working with dependency injection, we want this category repository's implementation to be injected. So first thing that we have to do is we have to modify the program.cs. So right here, we will have to add the category repository. We added application DB context, and then we are able to retrieve that with dependency injection. So here we want to inject something else. So we will say builder.services, and on there we have 3 lifetime when we want to inject something. The first one is singleton. Singleton, as the name suggests, will be just one implementation, and that will be used throughout the life cycle of the application. So until you restart your application, that implementation will stay there. When you are working with anything that relates to database, you should be using scoped reference. Scoped is basically limited to 1 per request. And what I mean is in a request, let's say you are hitting 10 endpoints, it will use the same implementation for 10 times. But if you use transient, like it is here, then if you are hitting an endpoint 10 times on one button click, then it will create 10 new objects every time. I explained this in much details in my dependency injection course, but this is the brief overview. When you are working with database, what you should be using is add scoped. And then here we will have to define the interface and its implementation. So the interface is category repository. We'll press Ctrl dot here to add the using statement, and implementation is inside category repository. We are registering this in our dependency injection container. So then in our Blazor page or anywhere in the application we want the implementation, it should be available to use. This should be category repository and not category repository. When we do that, we do not see a using statement. Let me go to the category, and of course this should be public. Let me do control dot here, and perfect. So with that, we have registered category repository in our dependency injection container. Let's continue in the next video. Now that we have registered our category repository to our container, how can we use that? Let me close all the tabs here, and we will implement all of that in the category pages that we have. The first one is create. Let's modify that. Where we are using the application DB context using dependency injection, we do not need that anymore. All we need is an iCategory repository and its implementation. We will add the using statement here, and let me just call that _db category. We need to get that using dependency injection, so let me paste that. And _db category is equal to category. Next, we will have to use this _db category inside the on post when we are adding something. Now the methods that we have inside the category repository is add, so we will use that, and it expects a category. It's not an async method, so perfect, looks good. Once we add the category, we will have to call the save method that we implemented inside the category repository right here. So that should function exactly the same, but this time we are not using DB context directly, we are using our category repository. Let me also modify the index page model to do the same. So first, we need dependency injection. Let me just copy and paste that here. This will be an IEnumerable as we had before. Let's not change that. And we'll add a using statement. The constructor will be index model. In order to get all the categories, we will say _db categories, and the method that we have is getAll. That will retrieve all the categories for us. So perfect. Now we are using category repository in create and index for the category page. Let's run the application and see if this works. Let's go to admin, categories, and perfect. You can see getAll is working as expected. Let's try to create a test category and see if that works. Perfect. Everything works with both of the functionalities. Let me delete that for now, but you can see we are implementing a repository pattern to access database and perform operations. Now for a second, think about what advantage this gives over directly accessing the DB context. The main advantage that we have is, let's say in future if you want to change the implementation of how the repository works, you do not have to come to the page model of all the pages in your application. You just have to go to category repository and modify the implementation right here, and that will automatically change how the implementation works. Also, if you want to change the root implementation of your repository, like let's say rather than entity framework, now you want to use Dapper. You just change the repository implementation here, and then all the application stays the same. So that will make this repository isolated and responsible for all the data related operation. So that will make your data tier loosely coupled from the complete application. Now with this implementation, there is one drawback right now. We have a category repository. Down the road, we will have a food type repository and all the repositories for the different DB set that we have. Then inside any page, let's say you are working with 3 tables. In that case, you will have 3 categories in the dependency injection that you will have to explicitly define right here. That is why an ideal approach is to create a unit of work that will wrap all of this repository inside one common umbrella. Also, if you examine in category repository, we have a save method. This save method is not dependent on any repository. Food type will also have a save method, But all the save method are not dependent on any models or DB set. It is a generic method. Once you save the changes, if you updated a category or if you updated a food type, everything will be saved. So it does not make sense to have a save method inside individual repository. Save method should be implemented at unit of work level because it is the parent of all the repository. So inside the category repository, we will remove the save method and we need to implement a unit of work pattern that will wrap all of the repositories. Let me show you how we can do that in the next video.